Welcome to the session, dear students. In today's session, I'm going to discuss an important chapter, that is inverse trigonometric functions. So one of the basic important chapter. Reason number one, this will be a part of differentiation also. If you want to differentiate a function, we have to simplify the inverse trigonometric function given. And also we learn inverse trigonometry and we'll apply it in other chapters like differential calculus. Second important thing is the basics of inverse trigonometric function helps you to simplify integral problems also. In integral calculus, in differential calculus, to simplify we need to be thorough with inverse trigonometric functions. And one more advantage of this is, if you want to become thorough with inverse trigonometric functions, you have to recollect the basics of trigonometry. And multiple angles, submultiple angles, allied angles, compound angles, whatever you studied in 11th or first year will be repeated while discussing this, so that it will become a revision and you will become thorough with both the topics. So now, without wasting our time, we'll start with the chapter that is inverse trigonometric functions. The very first thing is weightage. In your board exam, what is the weightage for this chapter? In your board exam, one mark question in part A. In part A, one question for 1 mark. In part B, two 2-mark questions they'll ask. In part C, one 3-mark question they'll ask. All of you know, part A are 1 markers, part B 2 markers, part C 3 markers, one 1-mark question, two 2-mark questions, 2 to the 4 marks total, and one 3-mark question. So total weightage is 8 marks for this chapter. One 1-marker, two 2-markers, and one 3-marker, total 8 marks. So in your board exam, if you see the past board papers, 8 marks will be from this chapter. Not only this 8 marks, I told you, this will become a basic to simplify the problems of differential calculus and integral calculus. So should be thorough with the chapter. If you don't learn the tools here, if you are not thorough with the inverse trigonometric functions, simplification to differentiate inverse trigonometric functions becomes difficult. So not only this 8 marks, it also helps you to score other marks in differentiation. Now we'll study. First we'll start with what is an inverse trigonometric function. You have studied trigonometric function. So in your first year PUC, you studied sine theta. So graph of sine theta, x is equal to sine theta. This is a graph of sine theta, that's what you studied. Maximum value of sine is 1 and minimum value of sine is what? -1. And this is a graph of sine theta, sinusoidal wave. So in your physics also, you'll study sinusoidal waves. This year also, you'll be studying so many concepts related to this. This is a trigonometric function. X is equal to what? Sine theta. Now if I transfer sine to the other side, if I transfer sine to this side, so theta becomes sine inverse x. Whenever trigonometric functions comes to the other side, it will become inverse trigonometric. So theta will become sine inverse x. Sine inverse x is called as inverse trigonometric function. You know, the x value, sine theta means x. X value lies between 1 and -1. That's why we'll say x belongs to -1 to 1. Means inverse trigonometric function called sine inverse x is defined when x lies between -1 to 1 closed interval. Why? Because from the graph of sine theta, we know sine theta is equal to x. This x can be +1 or -1 or between +1 and -1. It can take any values. That's what you studied in 11th. So now this is called as domain of inverse trigonometric function. What is meant by domain? Domain means possible values of x where function is defined. So your sine inverse x function is defined only between -1 to 1. And because of the graph sine, similarly we can draw the graph for sine inverse x also. So now just the basic required. If theta or sine theta is equals to x, then theta is what? Sine inverse x, provided x value should lie between -1 and 1. Similarly, if I take cos theta is equal to x, transfer cos to the other side, so theta becomes what? Cos inverse x. So theta is what? Cos inverse x. And here again, you know, maximum and minimum value of cos is what? -1 to 1. If cos theta is x, theta is cos inverse x, again x belongs to what? -1 to 1 closed interval. So we call this as domain. Domain means what? The set of values of x where function is defined. And range means what? Minimum value and maximum value are possible values of the overall function. Now we'll see the domain and range table. I hope all of you understood how to rearrange a trigonometric function and write it as inverse. So if they give inverse, we can convert it into trigonometric function. If they give trigonometric function, you can convert it into inverse. Suppose tan theta is equal to x. If tan theta is x, that implies theta will be tan inverse x. Similarly, if secant theta is x, then x is what? Theta is secant inverse x. So this is inverse trigonometric function. First, we'll become thorough with the domain and range of inverse trigonometric functions. You have to become thorough with the domain and range of inverse trigonometric function, because inverse trigonometric functions are not always defined. They are defined only when the values are suitable, that is here. So for sine inverse x, domain is -1 to 1 closed interval, and for cos inverse x, again domain is same. Tan inverse x, you can take all real numbers, minus infinity to plus infinity, and cot inverse x, all real numbers, and cosecant inverse x, mod x greater than or equal to 1, means cosecant inverse x, a number line starts from, means away from 1 and away from -1. Cosecant inverse x, for this domain, that is x belongs to, we can also write it as minus infinity to -1 closed interval union closed interval 1 to infinity. This is domain. So the other short form of writing this is mod x greater than or equal to 1. So now coming to this, sine inverse x, what is the domain? -1 to 1, cos inverse x -1 to 1, and tan inverse x, all real numbers, cot inverse x, all real numbers, cosecant inverse x, mod x greater than or equal to 1, or you can also write it in the form minus infinity to -1 closed interval union 1 to closed interval 1 to infinity, and cosecant inverse x also it is same, secant inverse x is also it is same, cosecant inverse x and secant inverse x, mod x greater than or equal to what? 1. Then range. For sine inverse x, range is closed interval minus pi by 2 to pi by 2, means minimum value is minus pi by 2. Overall minimum value of the overall function sine inverse x means y value. Y means sine inverse x. Sine inverse x value lies between minus 90 to plus 90, including minus 90 and plus 90, closed interval. And cos inverse x 0 to pi, closed interval. Tan inverse x, open interval pi by 2, minus pi by 2 to pi by 2, and cot inverse x 0 to pi, and cosecant inverse x minus 90 to 90 other than 0, secant inverse x 0 to pi other than 90. It is easy to remember, you know, cosecant 0 is not defined, that's why remove 0 degrees. And similarly, you know, secant 90 is not defined, so remove 90 degrees. So these are the reciprocals. Cosecant, secant are reciprocals. First memorize this table. Once you are thorough with this table, inverse trigonometric function table, then you can do the problems easily. Just I will summarize how to produce this table. It will take 10 seconds for you to produce this table, but this is a basic table. This is derived from the graph. Now what are the minimum and maximum values? First I will write domain. For sine inverse x, cos inverse x, tan inverse x, cot inverse x, cosecant inverse x, and secant inverse x. For these values, let me write domain. See, domain means values of x. So domain values of x -1 to 1. Sin inverse x and cos inverse x will have same domain, closed interval -1 to 1. But cot inverse x, tan inverse x will have same domain, all real numbers. And cosecant inverse x and secant inverse x, here it will have other than sin inverse x. You know, cosecant is the reciprocal of what? Sin. So here it lie away from 1 and away from -1, that is mod x greater than or equal to 1, or we can also say x belongs to mod x greater than or equal to 1 is one way of writing this, or you can also say x belongs to minus infinity to -1 closed interval, or 1 to infinity, closed interval 1 to infinity. So for cosecant inverse x it is the same, secant inverse x it is the same. So sin, cos, tan, cot, cosecant, secant. So these are the domains. What are the domains? Sin inverse x and cos inverse x, it is same. What is the domain? -1 to 1 closed interval. For cos inverse x also, x value should lie between same. But for tan inverse x, you can take all real numbers. You can write r, or you can also write minus infinity to infinity. Real numbers means what? All. Tan inverse and cot inverse x, all real numbers. cosecant inverse x mod x greater than or equal to 1, secant inverse x mod x greater than or equal to 1. You can see first two same, next two same, next two same. First two, sin inverse cos inverse x, what is the domain? -1 to 1 closed interval. Cos inverse x also -1 to 1 closed interval. Tan inverse cot inverse x, what tan inverse x and cot inverse x, what is the domain? All real numbers. Secant inverse x, cosecant inverse x, what is the domain? Mod x greater than or equal to 1, that is minus infinity to -1 closed interval union closed interval 1 to open interval infinity. I hope all of you understood. So these two are same, these two are same, these two are same. So what are the different domains? -1 to 1 or mod x greater than or equal to 1, these three domains. So for first two functions, -1 to 1, next tan inverse cot inverse, all real numbers, then cosecant and secant mod x greater than or equal to 1. Now range. So range for these functions, for this range -90 to +90. All of you know maximum value of sin theta is what? 1. Sin theta becomes 1 when theta is 90. It will become -1 when theta is -90. So -90 to +90 closed interval. For cos 0 to pi closed interval, 0 to pi closed interval. And tan inverse -90 to +90 open interval. And cot inverse is, see now we wrote these two, we'll repeat the same two open intervals. For cot inverse x, 0 to pi open interval, it is same as cos but open interval. Other than this, 0 to pi means excluding 0 and pi. Cosecant inverse x, same as sin inverse x, because cosecant is reciprocal of sin, same as sin, but remove what? 0, that is -90 to +90 other than 0 closed interval, this remove element 0. And secant inverse x is same as cos is what? 0 to pi closed interval, but remove what? 90 degrees, because at 90 this is not defined. So I hope all of you understood this. What I want to say is memorize the values. Once you are thorough with the domain and range, then you can do it. For sin inverse x, domain is closed interval -1 to 1. Cos inverse x, first learn all domains, then learn all range. What is the domain? -1 to 1, -1 to 1 for sin inverse x and cos inverse x. All real numbers for tan inverse x and cot inverse x. Mod x greater than or equal to 1 for secant inverse x and cosecant inverse x. What is the range? Closed interval -90 to 90 for sin inverse x, closed interval 0 to pi for cos inverse x, open interval -90 to 90 for sin inverse x, open interval 0 to pi for cot inverse x, and cosecant inverse x is same as sin inverse x other than 0, remove 0, that is -90 to 90 closed interval -0. Secant inverse x same as cos inverse x, that is 0 to pi, remove 90 degrees from it, because at 90 secant is not defined. Now I'm asking you people, before my next session, you should be thorough with this table function. If you are thorough with the table, then you can do the problems. ನೋಡಿ ಮುಂದಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಂದರೆ ಈ ಟೇಬಲ್ನ ತರವಾಗಿ ಕಲ್ತಿರಬೇಕು. ಅಂದರೆ ಡೊಮೈನ್ ಆ್ಯಂಡ್ ರೇಂಜ್ ಆಫ್ ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್ನ ತರವಾಗಿ ಕಲ್ತಿದ್ರೆ ಮಾತ್ರ ಪ್ರಾಬ್ಲಮ್ ಸುಲಭ ಆಗುತ್ತೆ. ಇಫ್ ಯು ವಾಂಟ್ ಟು ಸಾಲ್ವ್ ಎನಿ ಪ್ರಾಬ್ಲಮ್, ಫಸ್ಟ್ ಯು ಶುಡ್ ಹ್ಯಾವ್ ಪ್ರಿಸೈಸ್ ನಾಲೆಜ್ ಆಫ್ ಡೊಮೈನ್ ಆ್ಯಂಡ್ ರೇಂಜ್. ಸೊ ಕೊಟ್ಟಿರೋ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಗೆ ಡೊಮೈನ್ ಏನು, ರೇಂಜ್ ಏನು ಅಂತ ಗೊತ್ತಿರಬೇಕು. ಸಪೋಸ್ ಇಫ್ ಐ ಆಸ್ಕ್ ಯು ಟು ಫೈಂಡ್ sin inverse -3, sin inverse -3 does not exist. Why? Because so for sin inverse, inside we should have only -1 to 1. Domain means values of x inside the function, where function is defined. So please learn this function table. 6 inverse trigonometric functions, the domains and ranges. Become thorough. So in my next session, you write and practice. Write them twice and become thorough. Then you can understand the problems better. See, before we go to start with the problems of second year PUC, 12th standard ಅಥವಾ second PUC problem ಶುರು ಮಾಡೋ ಮುಂಚೆ ಫಸ್ಟ್ ಯು ಶುಡ್ ಬಿಕಮ್ ಥರೋ ವಿತ್ ಅಲೈಡ್ ಆ್ಯಂಗಲ್ಸ್. ನೀವು ಅಲೈಡ್ ಆ್ಯಂಗಲ್ಸ್ ಥರೋ ಆಗಿದ್ರೆ ಮಾತ್ರ ಪ್ರಾಬ್ಲಮ್ಸ್ ತುಂಬ ಸುಲಭವಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಫಸ್ಟ್ ವಿಲ್ ಫೋಕಸ್ ಆನ್ ಅಲೈಡ್ ಆ್ಯಂಗಲ್ಸ್. ಸೊ ಅಲೈಡ್ ಆ್ಯಂಗಲ್ಸ್, ಯು ನೋ, ಪ್ಲೇನ್ is divided into 4 quadrants, first, second, third, fourth. So the first quadrant, this is the second quadrant, this is the third quadrant, this is fourth quadrant. And first quadrant, see here you can see the angle between them is 90 degrees. So before 90, this is 90 minus theta, and after 90 this is 90 plus theta. Second quadrant 90 plus theta, and again we'll add another 90 degrees, so this will become 90 plus 90, 180. and again if I add another 90, this will become 270 degrees. So this is 180 degrees or pi. This is 270 degree line. So this is 9 after 90 plus theta, 180 minus theta. Third quadrant 270 minus theta and 270 minus theta and 180 plus theta. This is 270 minus theta and 360 minus theta. See here just 4 quadrants we have. Here to here we have perpendicular. This is 90. Another 90 if you add, this will become 180. Another 90 if you add, it will become 270. Another 90 if you add, it will become 360. So before this is 90 minus theta. After this is 360 plus theta. After this is 90 plus theta. And before this is 180 minus theta. I hope all of you understood how to divide and write the angles. So x-axis and y-axis. So this is y-axis and this is x-axis. You know, angle between them is what? 90 degrees. That's why I call this line as 90 degree line. And another 90 degrees if I add, this will become 180 degree line. Another 90 degree if I add, this will become 270 degree. Another 90 degree if I add, it will become 360 degree. Do you agree or not? So now before 90 is what? 90 minus theta. After 90 is what? 90 plus theta. And here this is after 90 and before what? 180. That's why 90 plus theta and 180 minus theta lies in second quadrant. And after 180, 180 plus theta. And before 270, 270 minus theta. So 180 plus theta and 270 minus theta. After 270 is 270 plus theta. And before 360 is 360 minus theta. So now this is after 360. So first quadrant is also called as 360 plus theta. First you should know. So first quadrant 90 minus theta, 360 plus theta. Second quadrant 90 plus 180 minus. Third 180 plus and 270 minus. Fourth 270 plus and 360 minus. And in first quadrant we say A. Alphabet is A. A means all trigonometric functions. So you people are good in telling all silver teacups that this. But first you should know A stands for what? All trigonometric functions. Sin theta, cos theta, tan theta, all are positive in first quadrant. S means sine and its reciprocal. S means what? S means sine and its reciprocal. What is the reciprocal of sine? Sine and cosecant. S stands for what? Sine and cosecant. T means what? Tan and cot. T stands for what? Tan and cot. C means trigonometric function starting with C is what? Cos and its reciprocal secant. So A, all trigonometric functions. Yes, sine and cosecant. So in second quadrant, sine and cosecant are positive. In third quadrant, T means what? Tan and cot are positive. In fourth quadrant, C means what? Cos and secant are positive. So before you start any problem, so first you should know the angle table and you should know the values of the quadrants. So how many quadrants we have? 4 quadrants. What are they? First, second, third, fourth. These are the 4 quadrants. And what is the first quadrant alphabet? A. A means what? All are positive in first quadrant. Yes, S means what? Sine and reciprocal of sine. Secant are positive here. And T means what? Tan and cot are positive. C means what? Cos and secant are positive. So A is TC. Then first quadrant is what? Before 90 degrees. So 90 minus theta and 360 plus theta. Second quadrant 90 plus theta and 180 minus theta. Third quadrant 180 plus theta and 270 minus theta. Fourth quadrant 270 plus theta and 360 minus theta. This is the quadrant system you should learn. ASTC and this. Now 2 rules. Rule number 1. For allied angles of the form 90 and 270, if it is 90 plus or minus theta, 270 plus or minus theta, function changes to co-ratio. Function changes to what? Co-ratio. If it is sine, it will become cos. If it is cos, it will become sine. If it is tan, it will become cot. Cot becomes tan. Co-ratio for sine, if the function is sine, it will become cos. Or if the function is cos, it will become sine. Function changes. For 90 and 270, function changes. What is rule number 1? If it is 90 and 270, function will change. And what is the change? It changes to its co-ratio. What is the co-ratio for sine? Sine co-ratio is cos and cos co-ratio is sine. For tan co-ratio is cot and for cot co-ratio is tan. For secant co-ratio is cosecant and if it's cosecant it will become secant. When we can expect change? The function changes if you expand in the form of 90 plus or minus theta and 270 plus or minus theta. If sine of 90 plus theta is cos theta, function changes. When function changes? For 90 and 270, function changes. And function does not change. No change in the function for 180 and 360. No change in the function for 180 and 360. So these are the two rules. What is rule number 1? For 90 and 270, function changes to its co-ratio. If it is sine, it will become cos. If it is cos, it will become sine. Tan changes to cot and cot changes to tan. And secant changes to cosecant and cosecant changes to secant. When can you see change? Change is possible when the allied angle is in the form of 90 and 270. For 180 and 360, no change in the function. So these two rules, and this, if you know, you can write allied angles. This I know all of you learned in your first year, but without this you cannot solve the problems of inverse. Just we'll take co-ratio relations. Before we go to co-ratio relations, let me write the allied angles for sine, and you do the same task for remaining trigonometric functions. First I'll take sine of 90 minus theta. Sine of 90 minus theta, what is the value? So just now I told you, first you should see whether the function changes or not. I told you for 90 and 270 function changes. When does function change? 90 and 270 function changes. And sine changes to what? Cos theta. Sine of 90 minus theta becomes what? Cos theta. And sine of, and I'll write positive cos theta. Why? Because according to the rule, so 90 minus theta is in which quadrant? First quadrant. In first quadrant, what is the alphabet? A means what? All are positive, so answer is positive. Then sine of 90 plus theta, again this is 90. I told you function changes to co-ratio if you expand in terms of 90 or 270. So this is 90, so function sine becomes what? Cos. And 90 plus theta lies in which quadrant? 90 plus theta is in second quadrant. In second quadrant, what is alphabet? Yes means what? Sine and cosecant both are positive. Your question is sine, so answer should be positive. Then sine of 180 minus theta. I told you for 180 and 360 function does not change. For 180 and 360 function does not change. So sine of 180 minus theta is sine theta. And 180 minus theta lies in which quadrant? So this is 90 degree line, this is 180 degree line. 180 minus theta is in second quadrant. In second quadrant, what is the alphabet? Yes means what? Sine and its reciprocal are positive. So sine of 180 minus theta is positive sine theta. And then sine of 180 plus theta. Again for 180 and 360 function does not change. So question is sine, your answer is also sine theta. And 180 plus theta. 180 plus theta lies in which quadrant? 180 plus theta lies in third quadrant. In third quadrant, what is the alphabet? T. If your question is tan or cot, then it is positive. But your question is not tan. So minus. Sine of 180 plus theta. First you should see whether the function changes or not. I told you function changes only for 90 and 270. This is not 90 or 270. So function does not change. Sine of 180 plus theta is sine theta. But I'll put minus. Why? Because 180 plus theta lies in which quadrant? Third quadrant. In third quadrant, what is the alphabet? T. T means tan or cot will be positive. But your question is not tan, it is not cot. So negative. Then sine of 270 minus theta. See, function changes for 90 and 270. So it is 270. So sine becomes what? Cos theta. And 270 minus theta lies in which quadrant? 270 minus theta is in third quadrant. In third quadrant, what is the alphabet? T. So your question does not match. So minus. Then sine of 270 plus theta. Sine of 270 plus theta. Again function changes. Sine changes to what? Cos theta. And 270 plus theta lies in which quadrant? 270 plus theta lies in fourth quadrant. Here what is the alphabet? C. C means what? Cos. Cos or secant. See, here we have cos, but you should see whether question is cos. Question is not cos or secant, so it does not match. So minus. Let me repeat. Sine of 270 plus theta. I told you for 90 and 270 function changes, so sine changes to cos, and 270 plus theta lies in fourth quadrant. In fourth quadrant, alphabet is C. It does not match with the question, so minus. Then sine of 360 minus theta. Sine of 360 minus theta. So for 360 function does not change. For 180 and 360 function does not change. Sine of 360 minus theta is sine theta, and 360 minus theta lies in which quadrant? It is in fourth. In fourth, alphabet is C, and your question does not match, so answer is negative. Then sine of 360 plus theta. Sine of 360 plus theta function does not change, and 360 plus theta lies in first quadrant. In first quadrant, all are positive, so your answer is positive. So now I wrote sine of 90 minus theta till this. My assignment to you people is simple. I am requesting you to complete this for all the trigonometric functions so that you will get grip of the subject. Do it for cos of 90 minus theta. Cos of 90 minus theta is sin theta. Then cos of 90 plus theta. Cos of 90 plus theta becomes minus sin theta. So first, to apply this, first you should know the rules. What are the rules? When function changes, when function does not change. When function changes, for 90 and 270 function changes. Function changes to what? Co-ratio. If it is sine, it will become cos. If it is cos, it will become sine. If it is tan, it becomes cot. And if it is secant, it will become cosecant. And when function does not change for 360 and 180. And you know the quadrant and alphabets. First quadrant A means what? All trigonometric functions. Second quadrant S means what? Sine and cosecant. And third T means what? Tan and its reciprocal. What is reciprocal of tan? Cot. Fourth quadrant C, cos and secant. Next, we need to learn co-ratio relations. Before we go to this, just I'll ask you a few questions. What is sine of 90 minus theta? What is sine of 90 minus theta? For 90, function changes to what? Cos. 90 minus theta is in first quadrant. So sine of 90 minus theta is cos theta. Similarly, what is cos of 90 minus theta? Cos changes to what? Sine. Positive sin theta. Similarly, what is secant of 90 minus theta? For 90 and 270 function changes. So if it is secant, it will become cosecant theta. And cosecant of 90 minus theta is what? Cosecant of 90 minus theta is secant theta. So my question to you, what is tan of 90 minus theta? See, for 90, function changes to co-ratio. Tan becomes what? Cot theta. 90 minus theta means first quadrant. All are positive. So these are the co-ratios. Sin of 90 minus theta is cos theta. Or cos theta can be written as sin of 90 minus theta, and sin theta can be written as cos of 90 minus theta. Secant can be written as cosecant of 90 minus theta, and cosecant can be written as secant of 90 minus theta. Tan can be written as cot of 90 minus theta, and cot theta can be written as tan of 90 minus theta using right angles. So 90 degrees. So pi means what? 180 degrees. So pi by 2 means what? 90 degrees. So in spite of 90, we can also say pi by 2. We'll start proving this. First, co-ratio relations. We need to prove sin inverse x plus cos inverse x is pi by 2. Then tan inverse x plus cot inverse x is pi by 2. Secant inverse x plus cosecant inverse x is pi by 2. Now we need to prove these three relations. So first, we'll prove sin inverse x plus cos inverse x is equal to pi by 2. And they'll ask you, and where x belongs to the domain -1 to 1. This is a standard question. So we need to prove this. First, take any one inverse trigonometric function. We have two inverse trigonometric functions. Take any one. So I'll take theta is equal to sin inverse x. What is the first step? Take theta is equal to sin inverse x. Rearrange this. So I'll bring sin inverse to this side. That implies sin theta is equal to what? X. Further, I need cos. Sin theta can be written as cos of 90 minus theta. Do you agree? So instead of sin theta, can I write cos of 90 minus theta? 90 means what? Pi by 2 minus theta is equal to x. Cos of pi by 2 means 90. Cos of 90 minus theta is what? Cos changes to sin. It will become sin theta. So instead of sin theta, can I write cos of 90 minus theta? Further transfer cos to that side. So we'll have pi by 2 minus theta is equal to cos inverse x. Transfer minus theta to the other side. So you'll have pi by 2 is equal to cos inverse x plus theta. That is pi by 2 is equal to cos inverse x plus theta. What is theta? Theta is sin inverse x. In the place of theta, substitute theta. So hence the proof. Pi by 2 is cos inverse x plus sin inverse x, or sin inverse x plus cos inverse x is equal to, we proved, is equal to how much? Pi by 2. Hence the proof. Understood? First, how to prove this? So sin inverse, they'll ask you to prove sin inverse x plus cos inverse x is equal to pi by 2, where x is in the domain, that is -1 to 1. So now how to prove this? Simple. First, take any one trigonometric function as theta. Let theta is equals to what? Sin inverse x. Let us assume theta is equal to sin inverse x and call it as equation 1. Transfer sin inverse to this side. I told you, if inverse trigonometry comes this side, it will become normal trigonometric function. Sin inverse ee kade bandre sin theta agutte. Sin theta is x. All of you know sin theta can be written as cos of 90 minus theta. So just now I told you allied angles. What is cos of 90 minus theta? So for 90 and 270 function changes, cos becomes sin. So 90 minus theta, cos of 90 minus theta becomes sin theta, and it is in first quadrant, so it is positive. In spite of sin theta, can I write cos of 90 minus theta and transfer cos to the other side, so it will become cos inverse x. So pi by 2 minus theta is cos inverse x. Transfer minus theta to the other side, it will become plus theta. So pi by 2 is cos inverse x plus theta. So now pi by 2 is cos inverse x plus theta. What is theta? Theta means sin inverse x. Substitute theta value. In the place of theta, put value of theta. Value of theta is sin inverse x. So pi by 2 is cos inverse x plus sin inverse x, or sin inverse x plus cos inverse x is pi by 2. And the same way you can prove the remaining. Now the second one, they'll ask you to prove tan inverse x plus cot inverse x is pi by 2, where x belongs to all real numbers. Now we'll prove this. So how to prove? Let theta is equal to tan inverse x. Call it as equation 1. Any one trigonometric, inverse trigonometric function you can take. Either you can take tan or you can take cot. So I took tan inverse x as theta. Transfer tan inverse to the other side, so it will become tan theta is equal to what? What is left out? X. Further, tan can be written as cot of 90 minus theta, or cot of pi by 2 minus theta is x, and transfer cot to the other side. So pi by 2 minus theta is equal to cot inverse x. Now call this as, so now transfer minus theta, go on rearranging. So pi by 2 is equal to cot inverse x. If minus theta comes to the other side, it will come plus theta, and substitute for theta. So cot inverse x plus theta. What is theta? Tan inverse x. Cot inverse x plus tan inverse x is pi by 2, and or will rearrange. We'll write tan inverse x plus cot inverse x is equal to pi by 2. So good. So now we are done with this. Similarly, you can prove secant inverse x plus cosecant inverse x as what? Pi by 2. Take secant inverse x as what? Theta, and theta becomes secant inverse x, secant theta becomes x. Secant theta can be written as cosecant of 90 minus theta. Rearrange, you will get it. Now your task is to remember all this co-ratio relations. What is sin inverse x plus cos inverse x? Pi by 2. What is tan inverse x plus cot inverse x? Pi by 2. What is secant inverse x plus cosecant inverse x? Pi by 2. And this holds here when x belongs to minus 1 to 1, and this holds for all real numbers, and this holds when x mod x is greater than or equal to 1. You know the domains. Okay, but memorize these three co-ratios. Always we can't sit and derive. To solve the problems, we'll make use of this. What is sin inverse x plus cos inverse x? Pi by 2. Three co-ratios relations. One is sin inverse x plus cos inverse x is pi by 2. Secant inverse x plus cosecant inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Memorize them. So I showed you how to prove it, and I also taught allied angles of first year PUC. I gave a task for you, that is write for cos of 90 minus theta, cos of 90 plus theta. Please sit and write for cos, secant, tan, all trigonometric functions, and memorize this. And remember the co-ratio relations. In my next session, I'll ask you the co-ratio relation. You should be able to tell the co-ratio relations, and some questions on allied angle I'll ask you. Should be able to tell. Once you are thorough with that, then I'll go ahead with next concepts. In today's class, I started two important things. One is domain and range table. I am requesting all of you to become thorough with domain and range table. So sin inverse x, domain is minus 1 to 1 closed interval, and range is minus pi by 2 to pi by 2 closed interval. Cos inverse x, minus 1 to 1 closed interval, and range is 0 to pi closed interval. Tan inverse x, domain is all real numbers, and range is 0 to pi, minus 90 to plus 90 open interval. Then cot inverse x, all real numbers is domain, and range is for cot inverse x, range is what? 0 to pi open interval, and cosecant inverse x, domain is mod x greater than or equal to 1, range is minus 90 to plus 90 closed interval minus 0, remove the element 0, and secant inverse x, domain is mod x greater than or equal to 1, and range is 0 to pi closed interval other than 90. That angle table you should remember, and co-ratio relations. Three co-ratio relations I taught you. Sin inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Secant inverse x plus cosecant inverse x is pi by 2. So the table of domain and range and co-ratio relations, you should be thorough. So in my next session, first I'll ask you those things. If you are able to tell, then we'll go ahead with the problems. In my next session, while solving the problems, we'll be applying whatever we discussed today. So become thorough with the range and domain and co-ratio relations. I'll see you in my next class. We'll start problems on simplification of inverse trigonometric functions and finding the values using allied angles. Thanks for attending the session. Thank you.